Hello everyone, I hope that you all are doing well. Today we solve a very interesting question, and this question is asked in IIT Exam 2024, and this question is from the real analysis part. Okay, what is given? F is a mapping from 1 to infinity of an interval to 0 to infinity of an interval. F is continuous. F is continuous and f of n, when n is a natural number, is defined in this way that f of n is equal to smallest prime factor of n. So let us realize this property by taking some examples. If we take n equal to 2, it gives f of 2 equal to 2 because 2 is the smallest prime factor of 2, and f of 3 is equal to what? F of 3 is equal to 3. F of 4 is equal to 2 because 2 is the smallest prime factor of 4, and f of 5 is equal to 5. If we will observe these examples, we can conclude a very interesting property which will help us to verify option A and B, that f of Pn is equal to Pn when Pn is a prime number. And option A and option B are saying about what? Limit x tends to infinity f of x, means whether this limit exists or not, limit x tends to infinity f of x. This property will help us to conclude this limit. Okay, what can you say about this limit? Because we know that there is no largest prime number, means Pn tends to infinity when n tends to infinity, because there is no largest prime number, and prime number set is also infinite sequence. From this, if we will take limit on both sides, limit Pn tends to infinity, f of Pn gives what? We know that f of Pn is equal to Pn, so limit Pn tends to infinity Pn, which is equal to infinite, so this limit does not exist. If this sequential limit does not exist, so the continuous limit does not exist, so this limit does not exist, means option A false and option B true. Okay, let us verify option C and option D. And option C and option D are asking about what? Option C and option D are asking about f of x equal to 2024. How many number of x exists such that f of x equal to 2024, means that number of points should finite or infinite, means if we construct a set A such that x belongs to 1 to infinity of an interval such that f of x equal to 2024. The question is about what? About the cardinality of A, whether A is finite or infinite. What can we say? Our claim is to claim. What is our claim? We can show that cardinality of A is equal to infinite. One can ask, from where you got the intuition that cardinality of A is infinite? Intuition, from where we are getting intuition? These properties will help us. F of Pn is equal to Pn. This property, and one more nice property is also there, that here f of 2 equal to 2 and f of 4 is 2, and if you calculate f of 6, it is also 2. For even number, for even natural number, it gives 2, means that it can be generalized. F of 2n is equal to 2 because 2 is the smallest prime for the even number. Okay, these two properties will help us, combined with a very interesting and celebrated property of continuous function. What is that? That is the intermediate value theorem. What intermediate value theorem? Intermediate value theorem says if f of A less than f of B, then f assumes all the values from f of A close interval f of B. F assumes all the values in between f of A and f of B. This is the interesting property for the continuous function f. Here main point is continuity. Okay, this property, star property, and these three things will come, and one more property is that Pn tends to infinity. These four property, okay, double star, star, double star, and this property and this property, these four property combinedly help us to conclude that cardinality of A is infinite. For that we should give a constructive proof, constructive realization. Okay, so for that reason we have to draw the number line. Okay, now we are doing construction. Suppose here is 2024 and here is Pn1 which is greater than 2024. We can find this because number of primes are infinite and it goes to infinite. So here Pn2, okay, here Pn3, n3. Now draw, now construct I, okay, I is equal to I1. Now draw, construct I1. I1 interval is what? I1 is Pn1 minus 1 close interval comma Pn2 open interval, this one, okay. And I2 is what? Not n2, it is n1, okay. I2 is what? I2 is Pn2 minus 1 comma Pn2 open interval, okay. Open or close, it does not matter, you can give also close interval, okay. Pn2 close interval, okay. And I3 is, means in general we can write I is equal to Pni minus 1 close interval Pni, okay, close interval. Means if you observe that here this number is a even number. Why? Because Pn1 is odd and its minus 1 gives even number. It is even number, it is even, and it is also even number. So what we will get? Pni minus 1 is equal to 2 because Pn, it is a even number, because when n is even it gives 2, okay. So it is 2 and f of Pni gives what? It is a prime number, prime one, so it fix, so it gives Pni, and Pni is greater than 2024. So by the intermediate value theorem, F assumes the values between 2 comma Pni, means there exist AI belongs to II such that what? Such that f of AI is equal to 2024, because 2024 belongs to this set. 2024 belongs to lie in this set, okay. So from this we conclude that if there exists AI belongs to capital II so that f of AI equal to 2024, okay. And these type of intervals I1, I2, I3 are infinite, and so number of AI, so we get a sequence AI sequence I from 1 to infinity such that what? Such that f of AI gives what? F of AI gives 2024. Claim is that AI one front is a distinct, all AIs are distinct, means claim is, we can write in this way, claim AIs are distinct, okay. Why AIs are distinct, okay. AIs are distinct because the intervals are disjoint. I1 intersection I2 disjoint, because I1 is where? If you look at the graph, Pn1 minus 1, it gives here this is, and Pn1 this interval, this interval, and Pn2 is what? This Pn2 minus 1, Pn2 minus 1 and Pn2, this interval, because it is I1, it is I2, this interval is I2. Okay, similarly this interval is I3. All these intervals are disjoint. From this disjoint property we can conclude that and small ai belongs to II, and these II intervals are disjoint, so we can conclude that these AIs are distinct. Okay, and so we get an infinite number of, so we got infinite number of distinct AIs such that what? F of AI equal to 2024. This implies cardinality of A is equal to infinite. So we get what? So we get option C is telling about that this set of the number of solutions of this equation is finite, so it is false, and option D is infinite, so it is true. So option B and D are true. I hope that you all understood it very well. Thank you all.